Logging is important, okay? So don't let it be an afterthought, and definitely don't forget it altogether. Anyway, we're interested in two types of logs: daemon logs and container logs. Sometimes we call container logs app logs, right? Well, the daemon logs are simple. These are the logs from the Docker daemon, or the Docker engine, depending on how you refer to it. Now, most modern Linux systems use systemd. In those instances, daemon logs get sent to journald, and we can read them with the journalctl command. If you're not on Linux with systemd, you might want to check in var log messages. On Windows, they go to appdata/local/docker, and you can also check the Windows event viewer. But the daemon logs are the easy part. Container logs or app logs, this is where the action is. Starting with the basics, Docker's hoping that apps log to stdout and stderr. Basically, the PID1 process in every container is getting captured and it's getting forwarded. So, design your containers so that your applications are running as PID1 and ideally logging to stdout and stderr. If you log into a file though, don't worry, it is possible to do symlinks and shunt writes to those files to stdout and error. Or, you could do something totally different and maybe mount a volume to those locations so that you can access them outside of the container and make sure they persist when the container's gone. Anyway, since about Docker 17.05 or 17.06 if you're using Enterprise Edition, Docker has supported the idea of logging drivers. These are plugins, right, that integrate container logging with existing logging solutions like syslog and Gelf and Splunk. The basic premise is to take the normal container logs and forward them to whatever logging solution you're already using, and most of the major logging tools have a Docker driver these days. Anyway, you set your default logging driver for the system via the daemon.json config file. Then, any new containers will start using that driver. If you've got the occasional container with specific logging requirements, no sweat. Just give it the --log driver and --log opt flags when you come to start it. That'll override whatever's configured as default for the host. Okay, by default, most Docker hosts default to JSON-file logging. This writes out logs to a simple JSON-file format. And it's cool, right, because you can use the docker logs command to view them. It's just docker logs and then the container name. And if you want, you can use -f to follow them and all that goodness. As well as that though, it's really easy to configure journald if you're on a Linux host using systemd. Aside from those two though, JSON-file and journald, which by the way both work with the docker logs command. But aside from that, we start getting into third-party specifics like configuring a Splunk server or whatever, and we're not getting into stuff like that here. Suffice to say, application logging takes the stdout and stderr streams and forwards them to somewhere else, syslog, Splunk, Gelf, whatever. And it all gets done via logging drivers, and we configure these in daemon.json. Brilliant. I'm thinking that's enough to get you going. Let's do a quick module recap. I'm going to make this quick because I've already talked longer than I planned. Containers are runtime cousins of images. Under the hood, they're an isolated application execution environment. We know it by now. It's a bunch of grouped namespaces that look and feel like a standalone OS. But containers are OS specific. There's no running Linux containers on Windows and vice versa, at least not without some magic going on behind the scenes. Because the thing is, containers don't contain a kernel. They have to talk to the kernel of the host. And Linux containers need a Linux kernel, and Windows need a Windows kernel. We also talked about containers being a thin writable layer that gets lashed on top of a read-only image using a combo of union mounts and a bit of copy on write. Brilliant. It's also cool if they can be ephemeral and immutable. Ephemeral being short-lived and immutable meaning we don't really want to be logging onto them and messing about. The idea, right, is once they're deployed, we should leave them alone. If we need to do a fix, you know what? Build a new image and deploy a new version. Keeping it short, what else? Yeah, we said the main process inside of a container is what it's all about. That process is usually going to be your application, right? Well, kill it and you kill the container. And login as well, right? That's also about that main PID1 process. And that's it. Well, it's not. I mean, we're only just getting to the good stuff. Coming up next, we're going to see how ridiculously easy it is to build a secure